Alright, so here's what we're going to do. I'm going to take the latest DragonOS Focal R16, which I just uploaded today, and I have an Rtl Sdr plugged in to a Intel NUC, which is what you see on the screen right now. I've also got a laptop sitting over here with the same build of DragonOS on it. And what I want to do is kind of work my way through different programs that are going to use the Rtl Sdr, just to kind of show how versatile the Rtl Sdr is and what all you can do with it. So I won't go too in depth on any one particular application. So we'll just check out a few different things. So first, I want to show a pretty exciting new program in DragonOS, which is called SDR4space. So if we look in the user source SDR space directory there, you're going to see an app image there and some examples. Alright, so best thing, let's take a look at the examples. We've got the RX and the satellite. I don't really have an antenna right now to really do much of anything with the satellite portion of this, so I want to take a look at the RX, and we're going to do a little modification to one of the examples. If you look up SDR4space online, you'll find a big README about all the different things you can do with it. Basically, it is to best of my knowledge, it's an SDR JavaScript virtual machine, which runs and then can carry out some tasks here. Let's look in the RX Spectrum folder, and we'll take a look at the simple spectrum. Now this is really set up for the Pluto SDR. So let's see if we can change this up some. Let's see, we want to look at the SOAPy driver that's used up here, and we'll change it to Rtl Sdr. Center frequency fine. Gain, you're probably looking more at, like, I think it's in the 40s for the Rtl Sdr. We'll try 45. Of course, we don't have that much or that high of a sample rate. We should be okay with 3 E6. And we'll change this from 10 to 3. So that's going to center on the 100 megahertz frequency, and for a total of 3 meg wide. We'll see kind of what the spectrum looks like. It'll pump it out into a CSV file, and then it'll use GNU plot to make us an image, all in the temp directory. So one thing I did notice is, let me think, because of the way I think that the app image is set up, it's best to, let's see, we'll do a symlink. Let me see, if user source SDR for space app image into let's see. Okay, so that I know that looked a little confusing, but basically I just made an app or a symlink to it here, because when you call upon it, it really needs the full file path of where the JS file is, but then the problem is it's also looking for the GNU file as well. So it's better to execute the app image directly from the folder you're working in. And we'll also take a look at, make sure our Rtl Sdr is seen. It is. Alright, so if we take a look at the SDR4space app image, alright, we can see that it runs, let's see, I think we can do a dash help. Let's see. Okay, So we want to specify the script file name. We might be able to use this working directory arg. Okay, but we'll just do this for now. So we'll do a -f and we'll do the spectrum.js file. So it's going to run this JavaScript file, finds the Rtl Sdr, it's going through, it sees the frequency ranges, and we should be able to look in our temp directory and we can see our spectrum CSV file with the frequencies and our power levels here. This should line up, let's see, with our plot. So we can see something on 99.5 megahertz. So if I come down here and I'm looking at 99.5, we can see the we got our neg, we're into the 60s now. And what else are we at here? So over next to 101. And we can see we're back down into the negative here. I just realized, let's see, antenna. It would help probably immensely if I actually had the antenna on the Rtl Sdr. So that was just with a long extender cable. So we'll do it one more time. Okay. All right, there we go. Now we can see, now let's compare that to our CSV file. Okay, now we can see better numbers here. 99.5, we can see we're into the negative 30s now. And so that lines up with this. Alright, so that's just a simple spectrum plot. Let's take a look at modifying our wide spectrum. And I'm using sudo because I'm in the user source directory. You could copy this SDR4space folder over to your desktop if that's easier, and you won't have to. Well, you still might have to use sudo because it's messing with the temporary directory. But let's look at the JavaScript for the wide spectrum. We'll do about the same thing here. Change our sample rate. I'm going to lower this down so we're not waiting so long, because we're only going to step about, we'll do 1.5. We're going to go from frequency 704 to 746. Might be something there, maybe some cellular. And we'll change this to 3. This is going to use GNU plot X11, and it'll pop up and be interactive. But if you had something, let's change the gain to, we'll do 45. Alright, and so what this is going to do is going to start at 704, and then it's going to go every up 1.5 megahertz until it gets to 746. We'll try this out. Again, I'll just make a symlink here. Okay, we got our symlink there. We'll do our -f spectrum.js. Alright, it's using our Rtl Sdr. We see it's started at 704. We'll let this go. Shouldn't take too long. In the meantime, we'll so after this, just know. Well, actually, I'll let that run there. If we look in the user source SDR4space example sat, there's some pretty interesting things here where it can kind of take control of GQRX and track some satellites. So that's a pretty cool feature. We're almost done here, by the way. Let's see, 743. All right, so now that may look a little funny because the way I did the step, I'll have to check and see if I've got that correct. That was just a best guess here. So now we can see the wide spectrum plot that is created, and you can see where you can hover over. You can see the frequency bottom left hand corner changing, and we got into this area here. And again, if we take a look at our CSV file, this should line up with the graph here. We can see started at 702 there because we had the 1.5 spread on there. And so there you go. Now you got a CSV file that corresponds to the image that we see in the background. So you can line up your results there. Let's see, 708, 04. We can see we can get drops down here a little bit. Let's see, 708, or that's actually 707, 976. So right in here lines up. All right, so that's a pretty I think unique feature here, especially if you wanted to reach out to something that may be sitting remote, and you could do those snapshots of the spectrum and then have that information available. And this is really only the beginning. There's so many I think possibilities with this that like I said, it's just chaining things together is what excites me. And then you can see here you can capture both a subband or the full capture, and there's each of them have readme files there that you can kind of see how they work and what they do. So basic capture, you can see record 8 meg samples is the example they give there. There's the capture subband, record a subband of IQ samples to disk, and then the last one is the best and recommended method to record IQ, and then you can see how that one works. So that's just a quick little intro to SDR4space. I want to dig down into that more on its own. So that's a unique thing now with DragonOS that's available in there with the Rtl Sdr. Let's take a look at what we can do with, let's see. So under ham radio, we've now got the most recent, let's see. Let's see. Now it might not be here because I was working on the NUC. What I'm looking for, okay, it's on the laptop. We'll take a look at SDR++. But what we'll do on this side, if we look in the user source Spyserver folder, we can see there's a config file there, which I'll just leave defaulted right now. And then we have our Spyserver, which will, in this case, run and allow the Rtl Sdr to be shared across the network. And so in the past, you've kind of had to use that, and then you've had to use a Windows application, SDR application to access this. But now, so we've got the Spyserver here listening on all connections on port 555. I'll jump over here to, this is the DragonOS on the laptop, just flashed a little bit ago. Under ham radio, we'll find the SDR++. And so now with this, let's take a look at our sources that are available here. And we'll try the Spyserver. And we'll jump back over, look at the IP address is 120.122 on the NUC. So we'll do 192.168.0.122. So we've got our Spyserver. We should be able to connect. I'm seeing it over on the NUC on my other screen here that we did in fact connect, which you can see here. And so now back on the SDR++. Now we're controlling the Intel NUC and the Rtl Sdr. And this now has the RT audio has been updated, so now we've got really good audio performance with, you can see here, with SDR++. Alright, something else we can do with SDR++, which I haven't used yet, the rig control server. So that was pretty new. I haven't tried that out. It's kind of interesting. If we do a quick little search here, we'll look up, let's see, virtual audio cable GQRX. This page here, in case I forget, we'll come down. Let's see, right here. And if we take this command, which I'll blow up the screen here, alright, so that's the command you want to copy and paste in. That'll get us a virtual sync. And so now, if we start back up SDR++, we'll see that we now have virtual sync. We'll connect back to our Spyserver. And the audio now is going out over the virtual sync. Let's see. We might be able to do, let's see, we'll open up. This is at least how you'd set it up. WSJT-X has also been updated. So if we come in here, we'll look at, we'll change FT8. Let's see, configurations, settings, make sure the input is the virtual sync. We can see we got audio coming in. I'm not going to be able to, I think, go down to 14.0, well, less than 20 megahertz, I think it is, with the Rtl Sdr, unless I put it into, I think it's direct sampling mode. Let's see what else we got. So what you'd want to do is basically get set up like this, have the proper antenna. You're probably looking more at the you're probably going to find more activity on the 20 meter, 40 meter, somewhere in there band for FT8. But at least this shows you how you can get set up with SDR++ with virtual audio to feed WSJT-X. Also, when you have this open, you want to expand out this window at the top here, and then you can see messages coming down in this waterfall display up here. Okay. Yeah, I'm really happy with the SDR++, and then you've got your frequency manager that's there now, and let's see what else. Yeah, okay. I'll go over this more in depth separately. All right. Let's see. I think let's take a look at one more thing in this, at least in this video. We'll jump back over to the Intel NUC, and what we're going to take a look at is let's see. Let's look at Suscli with SigDigger. What we're going to do is we're going to take the Rtl Sdr and we're going to make a profile that is going to be shared over the network to SigDigger on another computer. And the benefit of this is it's very efficient with bandwidth usage, and it can work outside the local network. And all the digital signal processing is happening on the Intel NUC itself, and then over on the laptop it's basically just going to be the shell that's presenting us the information and allowing us to control the Intel NUC and SigDigger. Alright, so we need to make a, let's see, we'll see if it sees the devices. Okay, we can see the Rtl Sdr is available. I had a B205 mini plugged in earlier, but alright, so that's available. Let's see if we have any profiles already created. Yep, there was the B205. Now let's make a profile. Oop. And we'll go ahead and make a profile for the Rtl Sdr. Okay, and then you can also edit that profile just like it shows there. And we can see this is for the B205 mini. We'll come down, we'll find the Rtl Sdr. I was looking for bandwidth, the default there. That's fine for this demo. 2.5 megahertz on the bandwidth and sample rate. You can specify where the start frequency, which is on 433. That's fine for right now. We'll save that. Then we want to run SUS CLI. We'll do take a look at the options again. We'll run dev serve and we'll do if equals 192.168.0.122. In my case, that's what the IP address is for me. So now we can see there's two ports that are being, I'm going to guess that the default source is probably still the Rtl Sdr, but we'll go ahead and jump over to the laptop and we'll remember 28002. So now we're over on the laptop. We can come down and find under ham radio SigDigger. The first time you start it, it might be, the resolution might make the top bar off of the screen. So if you just come down, you can either click minimize, or well, actually resize, or you can just maximize so that you can access the button in the upper right here, and then you can adjust it as needed. So we're going to look at changing the analyzer type to remote, and we're going to connect on that IP of 192.168.0.122, and we'll change it to 28002. We'll leave the username anonymous and password blank because I didn't set any of that up. And now we're going to connect. Come up here, turn run on. I can see over on the oh, interesting. So that was actually, let's connect on the default and see if that one is at 2 megs. Okay. So we'll jump back over to the NUC. Take a look here real quick at the sources. Oop. Take that up one. Jump back over to the laptop. 28002. Connect. Alright, there we go. Now we've got our 2.5 on the sample rate. Alright, so we're set up here. Let's check out we can turn our baseband on, which kicks on the, we'll take a look at that back over on the NUC. We can see it opens a request of an audio inspector, and this is all happening on the NUC. Back over to the laptop. Alright, so now we're remotely controlling that Rtl Sdr through SigDigger. All the processing is happening over on the Intel NUC side. We can even do an inspector if we want and kick over the data directly over here to process it further. Alright, and so you can have many different SDRs hooked up on the other end there to remotely control. So again, that's a really efficient way of running that. That is all done with the Rtl Sdr in this case. So like I said, a lot of different things you can do with it. I feel like I'll probably continue to do a few more videos just showing a little bit of everything that you can do with it, and then maybe dig down a little further, a little more complicated on each individual program and show some other things that can be done with it. All right, thank you.